Welcome to MWN.com. Dr. M.Wilson is happy to welcome all to this session. Greetings from MWN.com. Dr. M.Wilson, author, publisher, professor of commerce and management and formerly vice principal and head of Department of Commerce, Nagarcoil, is delighted in presenting this session. Thank you. Please subscribe the channel MWN.com. Chapter 8. Skewness, Kurtosis, Moments. The measure of skewness, kurtosis and moments analysis is about whether a distribution of variables is symmetrical or not. It measures the degree of asymmetric if the distribution is not symmetrical. It helps to study the real characteristics related to the symmetrical and asymmetrical of the data. Skewness. Skewness means asymmetrical distribution. If a distribution is asymmetrical 1, it may be called a skewed distribution. In a symmetrical distribution, diagram number 1, mean, median and mode are equal. When the value of mean is more than the mode, it is called positive skewness, diagram number 2. When the value of mode is greater than mean, it is called negative skewness, diagram number 3. Diagram number 1. Symmetrical distribution. Mean equals median equals mode. Diagram number 2. Positively skewed distribution. Diagram no. 3. Negatively skewed distribution. It is clear from the above diagrams that in a symmetrical distribution mean, median and mode are equal, whereas in the asymmetrical distribution the value of mean, median and mode varies. The asymmetrical distribution is positively skewed if mean greater than median greater than mode. In the negatively skewed distribution, mean less than median less than mode. Measures of skewness. Skewness may be measured either through absolute terms or through relative terms. Absolute measures of skewness. In absolute terms, skewness may be measured by taking the difference between mode and mean. Hence, the formula is well presented here. If the answer is positive, then it means that the distribution is positively skewed. If the answer is negative, it means the distribution is negatively skewed. Relative measures of skewness. Following are the important relative measures of skewness. 1. Carl Pearson's coefficient of skewness. 2. Bowley's coefficient of skewness. 3. Kelly's coefficient of skewness. 4. Measures of skewness based on moments. Carl Pearson's coefficient of skewness. According to Carl Pearson, the coefficient of skewness would be measured through the difference of mean and mode divided by standard deviation. The formula for Carl Pearson's coefficient of skewness is mentioned here. The result would lie between +1. If the answer is 0, since mean, median and mode are equal, then the distribution is symmetrical. If the answer is positive, then it is called positively skewed, and if it is negative, then it is called negatively skewed. In the absence of mode, the following formula may be applied by substituting the value of mode equals median to mean. The result of the coefficient of skewness through this formula may vary between +3. But mostly it lies between +1. Illustration. 1 represents individual observation. First column of the table is variables, second column is that's deviations taken from assumed mean. Assumed mean is 25. Third column is d square. Mean equals 27.11. Standard deviation is calculated through the formula, which is 8.4. Median is 25. Median equals th item equals fifth item, i.e., equals 25. Since it is difficult to identify the mode, the with only mean and median can be applied for calculating the coefficient of skewness. Calculation of mean and standard deviation. Based in the second illustration. Related to discrete series. First two columns are as given in the illustration. Third column is d, that's the difference between variables and assumed mean. Fourth column is d square. Fifth column is f into d. Last column is f into d square. Then sum of second, fifth and sixth column should be calculated. Then these values are applied in the formulas to know mean, mode and standard deviation. Then these values are applied in the formula to know the skewness. Illustration 3 is related to continuous series. Calculation of mean, mode and standard deviation. Based in the third illustration. Related to continuous series. First two columns are as given in the illustration. Third column is cumulative frequency, that's 3, then 3 plus 7 is 10, then 10 plus 12 is 22, like that. Remaining values should be calculated. Fourth column is mid-value, that's m. Fifth column is d, that's the difference between mid-value m and assumed mean. Sixth column is d square. Seventh column is f into d. Last column is f into d square. Then sum of second, seventh and eighth column should be calculated. Then these values are applied in the formulas to know mean, mode and standard deviation. Mean equals a plus or minus sigma d by n into c, it's 45.67. Calculation of mode. Modal class is 40 to 50. Hence, L equals 40. Delta 1 is F1 minus F0. Delta 2 is F1 minus F2. Mode equals L plus delta 1 divided by delta 1 plus delta 2 into I. Then standard deviation is calculated. Carl Pearson's coefficient of skewness is mean minus mode by standard deviation, that's equal to 0.08. Bowley's coefficient of skewness. Bowley's coefficient of skewness is based upon the quartiles of the distribution. This measure is otherwise called as quartile measure of skewness. The formula under this method is well presented here. As follows. Q3 equals third quartile. Q2 equals second quartile or median. Q1 equals first quartile. The value of this coefficient of skewness varies between plus or minus 1. Illustration. 4 represents discrete series. 3-column table is prepared. In first 2 columns marks and frequency is given in the illustration or written. In third column cumulative frequency is calculated. Q2 is 33rd item which is in 37 of the cumulative frequency column. Hence the value corresponding to the variables that is marks is 45. Hence Q2 is 45. Q1 is 16.5th item which is in 23 of the cumulative frequency column. Hence the value corresponding to the variables that is marks is 43. Hence Q1 is 43. Q3 is 49.5th item which is in 50 of the cumulative frequency column. Hence the value corresponding to the variables that is marks is 50. Hence Q3 is 50. These values should be applied in the formula to know the value of Bowley's coefficient of skewness. The value is 0.43. Please note that all coefficient values are less than 1. This illustration is to calculate Bowley's coefficient of skewness. This is a continuous series. To calculate the values, 3-column table is prepared. In first 2 columns expenses and frequency is given in the illustration or written. In third column cumulative frequency is calculated. Median equals n by second item equals 70 by 2 th item equals 35th item. It lies in class interval 60 to 80. Hence, L equals 60, CF equals 29, F equals 20, I equals 20, 80 to 60. Median equals L plus n by 2 minus CF by F into I. Q1 equals n by 4th item equals 70 by 4th item equals 017.5th item. It lies in the class interval 40 to 60. Hence, L equals 40, CF equals 15, F equals 14, I equals 20, 60 to 40. Q3 equals 3n by 4th item equals 3x 70 by 4th item equals 52.5th item. It lies in the class interval 80 to 100. Hence, L equals 80, CF equals 49, F equals 15, I equals 100 to 80 equals 20. Bowley's coefficient of skewness can be calculated through the formula and it's equal to minus 0.09. Kelly's coefficient of skewness. Kelly's coefficient of skewness is based upon the percentiles or deciles of the distribution. It covers the beginning and end of the distribution. Here the distribution is analyzed on the basis of the 10th and 90th percentiles. The formula is P90 plus P10 minus 2P50 divided by P90 minus P10. P90 is 90th percentile, P10 is 10th percentile, P50 is 50th percentile or median, D9 is decile 9, D1 is decile 1 and D5 is decile 5 or median. Sixth illustration is related to discrete series. To calculate Kelly's coefficient of skewness, 3-column table is prepared. In first 2 columns expenses and frequency is given in the illustration or written. In third column cumulative frequency is calculated. Median is n plus 1 by 2 th item, that's 110 plus 1 by 2 th item, that's 55.5th item, that's in cumulative frequency 63. The corresponding value of variable is median equals 49. P90 is 90 into 110 plus 1 by 100th item equals 99.9 th item, that's equals 57. P10 is 10 into 110 plus 1 by 100th item equals 11.1 th item, that's equals 37. These values should be applied in the formula of Kelly's coefficient of skewness. That is 0.2. Illustration. 7 is related to continuous series with expenses and number of families. To calculate Kelly's coefficient of skewness, 3-column table is prepared. In first 2 columns expenses and frequency is given in the illustration or written. In third column cumulative frequency is calculated. Median equals n 2 th item equals 150 by 2 th item equals 75th item. It lies in class interval 100 to 125. Hence, L equals 100, CF equals 60, F equals 25, I equals 125 to 100 equals 25. Median equals 100 plus 15 equals 115. P90 is 90 into 150 by 100th item equals 135th item. It lies in class interval 175 to 200. Hence, L equals 175, CF equals 124, F equals 12, I equals 200 to 175 equals 25. Hence P90 equals 175 plus 22.91 equals 197.91. P10 is 10 into 150 by 100th item equals 15th item. It lies in the class interval 25 to 50. Hence, L equals 25, CF equals 10, F equals 13, I equals 50 to 25 equals 25. P10 equals 25 plus 9.62 equals 34.41. Kelly's coefficient of skewness is 0.015. Moments. Moment in physics means movement of a force that turn a pivoted lever. But in statistics it means the characters of deviations from arithmetic mean of a distribution. Moment is related with the various powers to the deviations of variables from mean. The mean of the first power is called first moment, mean of the second power is called second moment, and so on. Moment is denoted by Greek letter pronounced as mu. Hence, the first moment is called, second moment is, and so on. Calculation of moments for individual observation. The procedure for calculating mu1 and mu3 are presented here. X minus x bar is deviations of variables taken from arithmetic mean. Mu1 will always be equal to 0 since the sum of deviations of the data from arithmetic mean is always 0. Calculation of mean for frequency distribution. That's for discrete series and continuous series. For the continuous series, mid-value, m, should be taken instead of x. 1. Skewness. That's beta 1 is mu3 square by mu2 raised 3. 2. Kurtosis. That's beta 2 is mu4 by mu2 raised 2. Moments based on arbitrary origin. The assumed mean can also be used for calculating moments, instead of actual mean. The moments calculated through assumed mean is called raw moments, which can be denoted as mu dash. It should be converted into real moments through other formulae. The details regarding these formulae are as follows. For individual observation, the procedure of calculating mu1 dash, mu2 dash, mu3 dash, and mu4 dash is given here. It's based on assumed mean instead of arithmetic mean. Hence deviations of data are calculated from assumed mean method. For frequency distribution, the calculations are same but f that's frequency should be used. C equals common factor. For continuous series mid-value, m should be used instead of x. Conversion of moments based on arbitrary origin, assumed mean, into moments based on arithmetic mean. The formulas are well presented here. Illustration. 8 is related to the calculation of the first 4 moments. Calculation of moments are based in the arithmetic mean. 5-column table is prepared. First column is variables Gian is in the illustration, second column is d that's x minus x bar. X bar is calculated as 7. Third column is d square, fourth column is d cube, fifth column is d raised 4. Sum of all the columns are calculated and are applied in concerned formulas to know. Mu1, mu2, mu3 and 4 dash is given here. Mu is called moments. Illustration. 9 is related to the calculation of the first 4 moments. It is a discrete series. 8-column table is prepared. First 2 columns are variables and frequency is Gian in the illustration. Third column is fx, that's cumulative frequency. Fourth column is d, that's x minus x bar. X bar is calculated as 40. Fifth column is f into d. Sixth column is fd square. Seventh column is fd raised 3. Sixth column is fd raised 4. Sum of all the columns are calculated and are applied in concerned formulas to know. Mu1, mu2, mu3 and 4 dash is given here. Mu is called moments. Illustration. 10 is related to the calculation of the first 4 moments. It is a continuous series. 9-column table is prepared. First 2 columns are variables and frequency is Gian in the illustration. Third column is m, that's mid-value. Fourth column is fm, that's cumulative frequency. Fifth column is d, that's m minus x bar. X bar is calculated as 35. Sixth column is f into d. Seventh column is fd square. Eighth column is fd raised 3. Ninth column is fd raised 4. Sum of all the columns are calculated and are applied in concerned formulas to know. Mu1, mu2, mu3 and 4 dash is given here. Mu is called moments. Kurtosis. Kurtosis is a Greek word, which means bulginess. It is a measure of the peakness or flatness of the distribution of data. Kurtosis measures the extent of the peakness of the distribution from the normal distribution. If the curve is more peaked than the normal curve, then it is called leptokurtic. If the curve is more flat-topped than the normal curve, it is called platykurtic. The normal curve is called mesokurtic. The diagrammatical representations of these kurtics are well presented here. First chart is leptokurtic. Beta 2, that's the value of kurtic is greater than 3. In mesokurtic, the value of kurtic is equal to 3. If the value of kurtic is lower than 3, it's called platykurtic. The kurtosis can be calculated through the formula beta 2 equal to mu 4 by mu square, that's moment 4 by moment 2 square. Illustration 11 value of kurtosis equals 7,000 4,225 equals 1.66. Since it's less than 3, the distribution will give platykurtic. For illustration, 12 skewness and kurtosis are calculated through the respective formulas. Exercise for skewness, kurtosis and moments are presented. Thank you. Please subscribe MWN.com. Thank you. Please subscribe MWN.com.